work energy theorem. Here work stands for mechanical work. In this theorem, work energy, this is mechanical work and this is mechanical energy. Mechanical energy is in fact the combination of kinetic and potential energy. It's normally written as W equal to delta K. Now, suppose the body starts from a particular place with velocity u and it reaches at an instant the velocity v. This is third equation of motion that we know. Multiplied by half m, we'll find half mv square, half mu square plus half m2as. This is kinetic energy final, this is kinetic energy initial, and this thing m into a, that's F, force. Force into displacement, that becomes work. If this thing is taken to left side, this would be minus sign, and here we can put sign of equality. Work is equal to change in kinetic energy. This is work energy theorem. Work done on a system is equal to the change in its kinetic energy. When the work done is positive, kinetic energy will increase. As in the case of gravity, when the body is coming down, K increases. Gravity does positive work. When the work done is negative, K will always decrease. This theorem always helps when the force is complicated. Without using the equations of motion, you can use this theorem. It also helps in understanding the complication of the problem when friction and other forces are also there. This in fact relates motion with force and energy. It is applicable when the forces are constant or even the variable forces are there. When the system is having one particle, then also this theorem is applicable, and when there are many particles in the system, then also this is applicable. Friction force or any kind of force, if all the forces are taken into account, this theorem always will lead to very accurate result. And it is frame dependent, means kinetic energy does depend on the frame of reference. Changing reference of frame, you will always observe some other value of kinetic energy.